So welcome back guys. So in our previous video, we look at how to um, how to integrate all powers of sine. So anytime that we see any sine raised to an odd power where that odd power is greater than 1, this is how we're supposed to do it. So in this video, we are also going to look at odd powers of cosine. So anytime that we see a cosine which has an odd power, that's how you're going to do it. So this one also has a rule. If you see any cosine raised to an odd power and you are supposed to integrate, you would split off one of the powers. One of the powers and use the function, the trigonometric function cosine squared x is equal to 1 minus sine squared x. So if you that is when you are given cosine to the m of x, where m is greater than 1 and m is odd. So you should remember this from longer time. If you did memorize the one for sine, which is sine squared x is equal to 1 minus cosine squared x, then you shouldn't worry about it, because anytime you can just make one the subject of the other. All right, so we will go ahead and solve a problem here, and I will explain as we go along. So in this problem, we've been asked to solve sine to the 4x cosine to the 5x dx. The moment you see this, you should look at the powers. We've not tackled even powers of sine yet, but we've tackled, that's what we just did, we tackled the odd powers of cosine. So we're going to take advantage of the fact that cosine here is raised to an odd power. So what does the rule say? It says split off one of the powers, and we should use this trigonometric function. So that's what we're going to do. This will be equal to, you have our sine 4x. We're going to split off one of the powers here. So if you do that, we're going to have cosine 4x multiplied by cosine of x dx. Then we're going to have sine 4x. This is the same as writing cosine squared x all squared multiplied by cosine of x dx. Now we have our cosine squared here, so we're going to just substitute for our trigonometric function. So this is the same as 1 minus sine squared x. Now we put that one in. We have sine 4x to bracket 1 minus sine squared x all squared cosine x dx. So what we're gonna do next is we just going to do a simple u substitution here, because we know we have sine x here. If you do substitute for sine x and we differentiate, we're gonna get cosine x dx. So we will let our u be equal to sine x, du to be equal to cosine of x dx. So we made a very good u substitution, because when we differentiate it, we have this guy here and that guy here to replace that. So we can use the guy there. So now what we're gonna do is we're just going to replace sine x with u. We're gonna have u to the fourth 1 minus u squared all squared. Then we're gonna have what du. So this is simple algebra here. Let's open it up. You're gonna have u squared, u to the 4, sorry. Then 1 times 1 is 1. You're gonna have 2 of those. That's FOIL. I don't even remember how FOIL is done. Alright. U squared plus u to the 4th du. Because this is gonna multiply itself, so. Then we're going to multiply this guy through. So we're going to have u to the 4 multiplied by 1. We have u to the 4 minus u to the 4 multiplied by 2 u to the 2nd. So we have 2u to the, if you multiply, add the exponent. So we have 2u to the 6 plus u to the 8 du. So now we go ahead and integrate. So we have u to the 5 divided by 5 minus 2u to the 7 divided by 7 plus u to the 9 divided by 9 plus c. So all we have to do right now is we have to just substitute our u back into the equation. So we have our u here to be equal to sine x. Replace all u's with sine x. So we have sine to the 5x divided by 5 minus 2 sine to the 7x divided by 7 plus sine to the 9x divided by 9 plus c. So boom, we solved the problem, and we've integrated that question we were given. We took advantage of the fact that we have cosine here, which has an odd power and which is also greater than 1. So whenever you see any cosine which has an odd power greater than 1, you use this formula right here. You split off one of the powers, then you substitute. You should be able to have that in your mind all the time, at least for this short period that you're taking calc to. Thank you, and I will see you in my next video. I'm going to work more examples on this, by the way.